Hello, welcome to episode 7 of Scala Project from Scratch. Last time we worked on the registry, like the initial implementation of it, and we got somewhere, and we'll just pick up from where we left off. So yeah, without further ado, let's get to it. So yeah, in the last episode we did this. We initialized the registry type, just to remind you what it looks like. It has a save and the lookup method. Then we have the resolver, which is responsible for taking a build and returning a resolved build. The only difference here is that the build has a base that can be an empty image or an image reference, but a resolved build will have instead a state, like a system state as the base. So it just resolves, like the resolver will go from an image reference or an empty build to a system state, so that we have a concrete value that we can use to build our image, so-called. Yeah, basically we go from a build to, after the resolution, we'll go from a build using the interpreter to system state. That's basically it. So yeah, so this is the current shape of it. And if my memory serves me well, we need to add some tests for these components because we don't have many. And yeah, then I had some more ideas for what we can do, like adding methods in the interface, like in the executor interface, so that the client could, like in here, so that the client could view the registry, or at least see what kind of hashes the registry has, because the registry has it's responsible for storing a system state and returning a hash of that state, so that we can retrieve that system by the hash later using the lookup method. This is currently, I think, only used for resolution of the build base. That's the only thing. No, wait, there's also, yeah, when we run in a system state, we also go from a hash. We look up and we yeah, we just return that. So yeah, so this is where we are, and yeah, it is time to add these tests and so on. But before we do that, I wanted to show you something that I prepared just before this. Basically, I wanted to have some sort of view on the whole structure here, like this architecture, and basically see where we are and where we are going to, and what these kind of components could evolve into. So the current shape looks like this. I use this chart for it. Currently it's, yeah, my face is glowing. Currently it's, yeah, I'm on the free plan. This is a very small chart, so it works. But if this outgrows the free plan, I might have to invest into it. So I hope you appreciate my dedication to the grind. But yeah, for now it's free, so that's fine. Also, I got a new microphone. It's on its way. I think I'll have it next week. So the sound quality here should get better, and I won't need this anymore. So yeah, here we have the current architecture here. The pieces that are in just black, this is what we currently have. The red pieces are going to be removed, like the empty hash as a method on the registry is going to disappear. And the blue ones are what we are going to add. This is just a note that this is what we're going to replace it with. And just to explain a bit more, the arrows here are basically the dependencies. I'm not showing like the data flow. This is what methods we are calling on these other components. And yeah, so the client-side executor is sort of standalone. Like the only thing that it really does, it's just call the server, and there's not anything else to it. Not much to it other than that. The server-side executor has 3 major dependencies. One of them is the resolver, which will take the build and return a resolved build. Then we pass that to the interpreter in the interpret method. So we go from a resolved build to a system state. And the resolver currently talks to the registry, and also the executor talks to the registry. It's asking the registry to save a system state. If we go to server-side executor, we'll see that after the interpretation, we have the save step. And also this is missing from this chart, but there's also a lookup step, which I kind of forgot. I guess I can add it now. But the server-side executor also uses the registry to look up by the hash. I'm not even sure if this should stay or not. But for now, let's just have it like this. So the registry is basically something that deals with hashes and states and just manages the kind of storage right now. So what I want to do here is split it a bit into a couple of things, because currently it has quite a few responsibilities. For example, the way that we store these things is currently hard-coded into the registry, so it's very well aware of what the underlying storage is. Currently it's a ref, and in the future it could be anything else. Redis, some SQL database, some NoSQL database, like Redis, or, you know, files on the disk. I was thinking of using SQLite on this. We'll see. Postgres would have been nice, because for Postgres we have non-blocking libraries. For SQLite, I'm not so sure. Anyway, this is just, you know, the technology choice that we shouldn't have to make right now. So one of the responsibilities of this module is this kind of like storage backend, currently a ref. Then we also have generation of the hashes, which are not really hashes right now. This is just a UID, and also like, yeah, talking to the storage and just looking up. So what I think we can do is like make this a very thin interface again. I really like thin interfaces. They are kind of a pain to test, because you certainly have like 7 layers to test one thing really, but it allows me to separate these responsibilities quite well. And I hope that this will indeed help us later. So we have the registry, and yeah, currently it's kind of like quite a big component. The resolver is not very big. What it does, I think we kind of split away the registry from it in the last episode. It's been a while, so I don't remember that well. But it talks to the registry by looking up using the empty hash and the hash. What I think we should be doing here, like we should just be passing, like empty hash should not be a thing. And I will try to get rid of this. And what I think we'll have here, like maybe there will be a hash algebra interface module, a hasher that will basically go from a state to a hash, and then we will be able to just use that to construct an empty hash by hashing the empty image, or yeah, basically the empty system state. So empty hash will be gone, like this will not exist. And to be honest, this isn't so much a method of the registry as like a helper, because it's outside of the module. But yeah, I want it gone. So we'll introduce hasher just to handle the hashing, and eventually there will be actual hashing. So yeah, I think we'll first start hashing and then extract it. And yeah, we'll also have a new component for the system storage itself, just for inserting and getting, nothing else, just a simple key value sort of thing. This will be possibly implemented with SQL or whatever. Currently it'll still be a ref. And there's also this new line here for the list. So this will take nothing and return a list of currently known hashes, just so that we can possibly display that in the client. In the future, this might be not just hashes, but like, you know, some metadata like hashes, tags, names, sizes potentially. We'll see. Like any kind of registry should have. I feel like it should have this kind of method. And naturally, this will need a method on the system storage as well, because we need to be able to like get all the keys that we have. So this is what this method is for. So this is going to be a fairly straightforward implementation in the registry, just calling this method. And this also will be pretty simple, as well as this. So yeah, this is gonna be the simplest part. I'm leaving it for the end. So yeah, so for now, I think we should add some more tests, like actual tests for these new modules, so that we can guarantee that nothing breaks when we do some refactoring. And later when we add the caching capability, this will change them a bit, because well, with hashing we can do better design, I think, than with just a registry that does randomly generated IDs. Yeah, I guess we'll see. First of all, the way that we currently look up existing systems in the registry, this was somewhere, yeah, like the save method here. Yeah, there was something shaky about this. Shaky, I'm not even sure. Shady, I guess, is the better word. So in the executor, when we resolve and then we interpret, yeah, I think this is the problem. So yeah, actually in here. So the problem is that we kind of look up by equality of the systems instead of looking at the hashes of the systems. So this seems kind of inefficient. Like we have to actually go through all the values in the storage to say whether the system is already known or not. So this kind of thing would disappear if we can calculate a hash of the system. So yeah, that would be nice to have. Yeah. Anyway, there's plenty of work here, but we'll start with these tests. And also, yeah, let me just run all the tests that we have. Right, that's not gonna work. Yeah, so this would be all the tests that we have. What I'm thinking about is trying out a different test framework. So instead of munit, I don't know, it shows up like that. Instead of munit, we would use Weaver. I think it is better suited to work with Cast Effect directly instead of having an integration layer on top of it. But maybe we can do this in another video. For now, I guess we can stay with munit. All right, so yeah, let me just have a look. And also, we're not doing Scala Steward today because we are not on the main branch. We are on the feature branch registry, and I don't intend to merge it into main until we are done with this feature, like the registry feature. So this might happen before the hash rate is added, but I don't want to perform that merge yet. I just merged main into it because I made some small changes to the README, but other than that, no change. So yeah, let's see. We have this for the interpreter, so I think this will not change much. Just a couple of them. We have tests for the routing, like concrete tests for the exact representation of the API. And we have tests for the whole server-side executor, which is using like all the real implementations. So eventually this might become like an integration test, or we might have to stub out some of the dependencies, like the storage, but I don't think we need to worry about that yet. Yeah, and also I have a worksheet. Yeah, this might be useful later. Yeah. So I was thinking about, yeah, something here was sketchy. Yeah, I think we should actually try out the Circe literal library. So what I heard is that it is available for Scala 3. I'm not entirely sure if it's released yet. Right, we don't have it yet. Yeah, let me see. So what's the latest versions of Circe? Yeah, 0.14.1. I don't think this will have that. So maybe we still need to wait for a release. Yeah, there's a milestone of 0.15, but I don't really feel like using a milestone at this point. So yeah, let's forget that for now. Okay, yeah, tests. I keep switching the topics, I know, but I hope you are okay with that. So yeah, we have the resolver. Now let's see what kind of stuff we would be testing here. This will need a registry. Maybe it's easier to test this first. Yeah. So the problem with the registry is that the generation of the hashes is not deterministic. Like we need a UID gen. I guess the question is how we create these. And yeah, it seems like there is no like method to create this with like a seed. So this will be very, very random. And that is going to cause some problems. But I guess we can work around that. Like some of the tests I think I can write without this being a problem. Let's try. So I'm gonna copy paste because I never remember how to write this. I'm just gonna call it registry tests. And yeah, I guess now I can remove everything except one test to do. We will need some system states and some hashes, but for now I guess just system states. Let's just have this. So I'll need an arbitrary, and this is the point where I have to define like a place where we'll be putting this. And I guess this should go into shared. Yeah, both hashes and builds and result builds. No, I guess result build is a server only thing. So yeah, let's just do it for now here. So the pattern that I usually follow in my work is I put these in a giant arbitraries object. Maybe I will split it by like package. And I guess this. Yeah, we should have some sort of packages for the backend and the client, like the server and the client. But I don't want to deal with that right now. Yeah, this is my project. I can allow myself to do this kind of thing, but yeah. Okay, now we'll need to actually import that. Right. Okay. And this is not working because... Oh yeah, I need to do like given. Yeah, okay. By the way, shouldn't there be like a Scala 3 derivation for this? I guess it's not that difficult to write it by hand, but yeah, we should look for like a library to generate arbitraries. Maybe later though. So we have this here. I probably should reuse it here as well. Okay. Do we need this still? Yes. Okay. So I'm gonna write, just start running these tests. And only the registry tests in watch mode. Okay, this is failing, that's good. So yeah, the first test that I would like to have is, what if I save something and then I look up? Like this should always succeed, right? With the result of the first method. So save plus lookup. Returns the same system. Yeah, this is kind of interesting. So right now the registry, if you tried to yeah, I guess this is fine. Because the save method doesn't take a hash, and there's no risk of like trying to insert two different systems under the same hash. Like this is not going to happen because the hash calculation happens inside. Like you don't pass the hash to the registry when you're inserting. So that's good. In the future it might be an issue, but yeah, we'll need to just make sure that you cannot overwrite. Like the registry should be like append only, with the ability to like erase old states, but you should not be able to overwrite them. And also like hashes shouldn't be allowed to glide, but that's a different problem, a bit different. So yeah, I'll need a system for sure, and I guess I'll just need a registry as well. So yeah, let's have the in-memory one. It shouldn't be named this way, but yeah. I'll need an IO because we need ref make. I guess sync IO would also be fine, but I'm not a fan of it. Especially when we don't need sync IO. I mean, like sync IO, the type. This one. So, what I'm gonna need. Yeah, so this is what Weaver would have done nicely, like provide a shared resource for all the tests if we wanted one. Now I'm wondering whether I can reuse this resource potentially. Yeah, there's nothing like this here, is it? Yeah, let's just assume there isn't. Oh, this is just Scala check, by the way. So I'll need also Cats Effect Suite, I think. Because this was implemented with ID. Yeah. So let's try this. I wonder if it's gonna work. It's not a trait, okay. Okay. Yeah. How about assert IO? I can never remember this. Yeah. Okay, maybe this one. So like IO, true and false. And this is wrong because... Wait, are you telling me that we don't have any tests like this? With IO? It certainly looks like this. Okay. Okay. Yeah, I'm gonna have to look up a unit. Cats effect. I'm pretty sure this works in Weaver, so this would be a strong reason to switch if we cannot combine Cats effect suite with property-based testing. So I'm gonna look here. Okay, that's not good. Okay, I don't think it's gonna work. So it's time to switch. I didn't want to, but now I have no choice. Or at least I choose not, I choose to think so. So I'm gonna probably just call this a refactor. Create arbitraries. Let's call it this way. Yeah, it's time to bring in Weaver. So, so this is Weaver. It's a Disney streaming library. By the way, that's my current employer. So cat effect usage, Scala check integration. Yeah, IO checkers is a thing. So it seems like you should be able to do this. But for now, it all seems like it doesn't have any like IO in the props. Okay, let's just try it out. Let's just try it out. So in the server, right? No, I guess I can add it to the shared ones since it's just a test thing. So just this. And also, I think we need a different version for Casifag 3, like 07. Okay, I can see it here, but yeah. Yeah, 079 I think is the version that we need to use. So yeah, let's see. So in the meantime, I definitely need to add the test framework, and I probably need WeaverCast as well. Right, this will be a separate thing. Okay. Okay. Yeah, let's import. Oh, wait, wrong version. Interesting. Why does this not? So I was expecting that this would fail because there are conflicting versions of Casifag in scope. But maybe not. Maybe SBT doesn't care. Or maybe this is not being used for some reason. Yeah, let's try this. Okay. Yes, I know I need the asterisk. Okay, so this would be an IO suite. And it should be an object. Okay, it's simple IO suite, I think. So this is like a simple test. It's going to work with like this way. But I need the Scala check integration. So we'll also need checkers. Okay. Yeah, let's do something simple. So I guess that's foo for all. Let's try this and something like IO print line I as I result assert equal result and I, something like this. Let's run this and then break it. Yeah, I think it works. Yeah. Okay. Yeah, I'm just gonna use this. So for now we'll use it in this suite because all the others are still gonna work. Let's just confirm that. And later I think we can add, like refactor all the other tests because this is surely better if I can combine these two things. And also I guess you could say I don't need IO, like I could refactor some other components like this storage, I think is what we called it, system storage. But yeah, I don't want to do that specifically for, you know, writing tests. So this is gonna be a test. And this is going to be for all lowercase. And yeah, let's try this. I mean, I don't have to try, I know it's gonna work this time. Right, I'll need to show. So also next to the arbitraries, I'll have like yeah, let's just put it here for now. Or I can put it into the system state companion object. Yeah, let's do that. I'm just gonna do show from to string because I'm lazy. Now this should work. Or at least compile. And now it's gonna fail. Good. So yeah, what I wanted to do, we're gonna do registry use. Actually, let's call it registry R, and this is gonna be called registry. And now we can do, let's go registry save system, flat map hash. Now lookup by the hash, registry lookup. Map result. This should be result equals some. Actually, I can do contains, and this will contain the system. That's right. And it passes. So how do I know this is actually running? Let's try with an empty system, like a system state empty. Yeah, okay, now it's failing all the time. This is not very printable. I'm surprised my computer can handle this kind of text in the output. Yeah, okay, so we can consider this a test. So this works. Let's see if I can clean it up a bit. I think it's fine. So yeah, the question is whether I should share the resource. I guess I need to look at the parallelism, like in here. Parallelism. So what are the default? So all the tests in a suite run in parallel. Okay. Yeah, so because of this, I don't think we can safely share a resource. That might be a problem. So I'm gonna just keep using one resource per test, like this, so there will be a use here. So yeah, registry save. This looks right to me. I guess we could try rewriting this as a for comprehension. We have the hash, we have the result, and we assert what contains system. Okay. Yeah, that looks good. So now, the other test that I wanted to have is something like lookup called twice in isolation, like with no other things happening, should return the same thing. But first we'll need to actually insert something, I think. Like, yeah, whether we insert or not, this should be true. This would work better if we had like an artificial registry, like if we had a generated registry maybe even, but I don't think I have that. I probably can't do this. It wouldn't work very well. So yeah, let's just try to do this manually, sort of. So multiple lookup returns the same system every time. Same value. Or just like lookup is idempotent. So we'll need that system. And yeah, I guess we can even have a list of systems. And the hash. So I'll need an arbitrary hash, I guess, which I don't have yet. So this is gonna be gen, what is the hash again? Just a case class over vector byte, okay? Yeah. And I don't have a show. Oh, this is gonna be fun. Actually, this should be a given show. Let me think. Yeah, right now it's just like arbitrary bytes. I cannot print that as a string. I could convert these bytes to hexadecimal, potentially. Yeah, to be honest, that might be it. So yeah, I'll need this eventually, and I think maybe this should be this toString as well. Yeah, let's just say 2 hex. And this is going to be made from that. Yeah. Now I can't remember exactly like what the best way to do this is, to convert like an array of bytes to hexadecimal. I'm just gonna Google it. How do we do this in Java? Because it's gonna be the same thing, I think. Oh my goodness. Yeah, I don't want to do that. Is there like a simpler way without libraries? Okay. Wait, do we have like could I make this a number? Probably not, it's gonna be too large. Yeah. So this is probably going to be pretty inefficient. But because it's just going to be for like display, we're not gonna do it all the time. What's the difference between this and this? Okay, I'm gonna try this one. It seems simpler. So yeah, buffer, this is gonna be just value like this. Yeah, let's try it in the worksheet. So we will have some sort of hashes here. Yeah, let's try this. That seems okay-ish. Can I do it in like lowercase? Okay, that doesn't actually change the casing. Okay, yeah, I'm just gonna use this. It does the job, like displays some sort of string. So I think we're good. Now. Just checking the time, okay. So yeah, we're definitely gonna look up by the hash like once and twice. And I want to assert that these are equal. So right now it's gonna be fine because they will be none, both. But I think we should insert these like list of systems before. So systems, traverse, registry save. And then need to import some cats. And yeah, that works. Yeah, you could also say that if we insert some more systems here, this should also be true. So more systems. So yeah, I think this is quite a useful test. Like it tells us really that this doesn't change when you insert more stuff. Okay. I wonder if it's always none. Like, let's just assert that for fun. Is empty. I hope not. Like if we get this to fail sometimes, that would be cool. And it is pretty cool. Yeah, that's nice. So it means that there is some clash between the systems and the hash, which is what I expected, what I wanted. That's really good. Okay, I'm gonna leave it like this. So lookup is input, and what else? So if I save a system and I try to save it again, it should have the same hash. So save is also idempotent. So I don't really need to use the lookup method here. I'll just save it twice and say that hash is equal to hash2. Okay. This takes a second. Wow. Okay, and I guess like even if we insert other stuff in between, it should still be the same. I was thinking if I should make this a separate test, but probably not. Yeah, let's take some more systems. So other systems. Now it doesn't really matter if this list contains this item, like this one, because we will save them right here. String. So we save the system first, and then we try to overwrite it with other systems, which potentially have the same instance as well. But it will still return the same thing. So I guess we don't need this. So maybe, oh yeah, okay. Okay, this is like 2 tests in a trench code. So yeah, let's skip this for now. Let's get back to the previous test. So these two are the same. And then save is eternal, not affected by other writes. So we write one system, we write other systems, and now we should be able to look up. Isn't this the same thing, you know? No, I guess it's not. Like save plus lookup. Yeah, if I try to now retrieve this, yeah, I'm wondering whether I should use lookup or save here. I think, yeah, save is fine. Otherwise, it kind of starts looking like this test. So yeah, let's save. So if you look closely, this test is this test when this is an empty list. So I don't think we need this one. It actually covers both cases. Okay. All right. Yeah, I think this is good enough for now for registry. Okay, my shell broke. Let me open a new one. So now I'm gonna probably not rewrite all the tests yet. Let's add a new spec. So this is gonna be for the resolver. So it's gonna be an IO suite. Simple IO suite. I always forget it. And this as well. And yeah, do I actually need property tests here? So resolve is, yeah, it's kind of weird. So it uses a registry. Yeah, this is giving me hints. So I'll need like a test registry instance. And yeah, let me just write down what cases I would like to have. So resolve empty image. So when we resolve an empty image, right? Yeah, let's just get back to the main thing. We have a build. So when we resolve an empty build, we should have like a concrete output value, I think. Like a resolve build with just an empty image as a base and no commands. It should be a resolved build with whatever the hash is. But this will depend on what the registry says about the hash. Okay. Yeah, I think we'll need some sort of in-memory registry. But I'm not really a fan of like the idea to implement a whole new registry just because I don't want an actual like ref in the backend. I would like a ref-backed registry actually. And I would like this to be the case even when we have a registry backed by something else. So this in-memory thing will probably have to stay, but it will like wrap around the creation of the backend and the registry. Yeah, let's see. So if I save the system state, then when I use this hash to be resolved, that should work, I guess. And also the resolution of the commands is pretty trivial right now, so I guess what this really does is resolve like call out to the registry. So we'll just need to support like resolve with a existing hash, resolve with a non-existent hash. What else? Like yeah, this case like a missing base. We'll probably not exercise this branch, and also this is not gonna exist in the future, I think. We'll see. Right, does the registry actually have a hash for the empty system? It does. So we technically could, I guess, test this. Yeah, I think we are. So maybe resolve empty build. Yeah, okay. I think I even know how to use property-based tests here for like the commands. Although, if I generate the commands, yeah, I guess we can ignore them in the output. I basically don't want to rewrite this logic or extract this as a method that we will be calling. And if we were to compare the whole resolved builds, we would need to basically do that. So I think I can like ask it to resolve a build with a concrete base and arbitrary commands, but I'll only look at the base in the output. I hope it makes sense. So yeah, let's try that. But I'll need a resolver. Let's actually try to write one test. So maybe for the empty build. Do we still have an empty build actually? We do. That's good. And actually it doesn't have to be an empty build. It can be just the empty system as base. Empty base. Yeah. Empty image base. Okay. So I'll need the checkers. And I'll definitely need the arbitraries. So test solve any build basing on the empty image. So for all commands, list of command, build.command. And we don't have an arbitrary command of list of build command. It's interesting. Oh, we have an arbitrary of the results commands. That's interesting. Yeah, let's. I keep saying things are interesting, aren't I? Let's just use build here. The structure is the same, but what's wrong with you? Oh yeah, oh yeah. This is so annoying. Like, Scala was supposed to save us from this. Like, you don't have to come up with a name, and now suddenly you have to. So, these are the same name. Arp, resolved command. Yeah, that was fine. But it's really annoying. I think the compiler should like, do something about this. What's the problem here? Okay, something is wrong here. Why doesn't it see? Oh, yeah, of course it's wrong. So now we need the show. So I think we can add it for the command as well. Command in result build. This one. And also I think we should be using this in the toString, so okay. Yeah, I mentioned command. This will go here. Okay. Yeah, that's good. So we have any list of commands. Yeah, let's try to build everything manually for now. So I'll need a registry, in-memory IO. I'm gonna use this. Now I will need the resolver instance. And with this, we're gonna resolve build, and the base will be empty image, but the commands will be the generated commands. And I want this. So the new base has to be resolved. No, wait, the new base will be, what's a resolved build? It's always a system state. So we're gonna have system state empty, no? Where does that live? In the registry? Yeah, I guess we can ask the registry actually. So, resolved. Yeah, we're gonna have resolved here. We're also gonna ask the registry to look up by the hash of registry empty hash, and then map to a result. Yeah, first I'm gonna like validate this, so almost. So we have fail. What else do we have? Failure. It's still an expectations value. I want something else, like fail fast. Fail fast. Yeah, this is what I want. But that's a unit. Why is this unit? Oops. Wait, so there's fail. Fail fast. Where's this available? There's expectations. Oh, you can take an expectation value and fail fast on that. But still, it's unit. Oh, so it doesn't fail on successful ones. I see. So I could just raise the expectation, a failed one, as an exception. Yeah, I'm not a fan. And also we're kind of duplicating stuff from the resolver here. Okay, I'm just gonna hardcode this to what the registry considers the empty system. Why don't we do it like this for now? And this will be map. We're gonna run the resolver test. Okay, so that would work. Now let's see if I can break the test. Yeah, okay. Yeah, at least this is kind of readable. Kind of. Okay, anyway, this test works. So the empty image is a base. Now if it's anything else that already exists, we'll have a pretty similar test. So maybe we can extract something. Maybe this, I could have any commands test. Let's see. No, that's probably not a good idea. Yeah, let me just try to do this, like just repeat myself, and then we'll see if there's anything in common. So, an existing image. So I'll need some sort of system state. I will put that into the registry. So registry save system. And this is now my hash, base hash. And when I have this hash, I can use it as an image reference. And when I resolve this, the new base is gonna be the system. Okay. So that worked. So apart from this insert, this is pretty much the same code. So I'm gonna write it like this. So save system, then resolve. Resolve is system. That's basically it. Yeah, if we write it like this, it might be nicer. What is it complaining about now? Yeah, sometimes you just have to connect back to the IDE, or to Bloop actually. Okay, what else? Build, resolve, build. So the reason why I'm not doing like resolved.base here is that the assertion will look better if I don't. If I change this, so now the assertion fails, and if we scroll up, yeah, we have this like, I can't show this really well here. I'm just gonna show this in a smaller example. Foo. So assert, well, let's make a pure test. Doesn't really matter if there's IO involved or not. So imagine this, like file actual will be list sum 42, and expected is something like list sum 45. So if you say actual is equal to expected, you're gonna have a failure that looks like this. So it'll show you every part of the expression. So actual, this is what it is, expected, this is what it is, and then you get a false for the equals here. If I write this like this, if I just inline this, it's gonna change the output here. This is just because it's based on macros. So on this side we have, like now we'll get more detail on every part of this expression. Like we'll have this separately and then this, and you can do it for both sides. So if you say like length equals length here, this will succeed. But if I have two elements here, now it's gonna be different, and you'll have this very verbose response. In here it actually makes sense, it's actually pretty useful. I'm not convinced that it will be very useful here. I think like the base is the only part that matters. Length is kind of like a derived output, but what I'm doing here, I'm just focusing on a field. And by focusing on a field, it allows me to not involve the rest of this class in this test, in the output as well. Okay, so we have that. And if we use a non-existent hash, I think this is easier. We just do the same thing, but we don't insert. Yeah, let's just go like this. Resolve with an unknown hash fails. We will just not call the registry. We'll just make up a hash. And because the registry is fresh, I can probably take an arbitrary one. And this is now gonna fail. It did, so we got a null. Interesting. Wait, did we actually get a... Oh, it's probably null because there's no like no message of the error. That's fine. So yeah, I think I need like a tempt, and yeah, and I'm gonna assert that the result is a left unknown base. And the hash here. Okay. See, now I got a quite verbose thing here. But I got something like this eventually. Let's see. So there's a left. Wait, what? It succeeded. Okay, so it succeeded. For some reason we have a right. And there's a base at like the empty system. And a bunch of commands. But I never insert anything into the system. Are we sure this is the right test? It is. And there's more of it. I mean, this is probably the same thing, but this just repeats the error message. Okay, let's see. So why would this be a right? Let's look at the resolver here. Oops. This is so funny. I got a very small window. Like, this is what you do when you double click on Mac. What the hell? So dumb. Okay. So when we try to resolve, we're gonna try to resolve the base. Oh, it generated the empty hash, which is known by the registry. So I would need like in memory, but empty. That's so ridiculous. So what we're getting, we're actually triggering this case. So yeah, yeah, it's actually trying the empty hash, and because it's known by the registry, we're kind of doomed, and I cannot delete that hash from the registry. Yeah, that's a problem. So I shouldn't have a condition here. I should note that hash is the empty image hash, because that would sort of ruin the whole purpose of property-based tests. I don't think you should have like this kind of checks in this kind of tests. Let's see. Yeah. So how can I guarantee that whatever hash is in there is not the empty one without changing the generation or adding conditions? So the first thing I'm thinking of is create just a new registry, the kind that doesn't have an empty hash in the initial state, and possibly like put the insertion of it into some other module. Yeah, actually that seems like a decent idea. So we'll have instance and just in memory. Something like this, maybe. I think for now it's a decent idea. So I'll have an empty map. And also the empty hash, how do I get that? Also this. Yeah, what I'm thinking here is to just remove the lookup here and actually try to insert the empty image, because insert also kind of serves as a lookup because you get a hash in the output. Like this could be our empty hash. It doesn't have to be hard-coded in the registry. But then this would be the work of a hasher, not a registry, really, to just define what this hash is. We don't need to actually call to the backend. And yeah, okay. Okay. I don't know. The problem that I'm having now is like, how do I call save on this? So maybe I can like take a parameter of some initial state. Let's do it like this for now. So map of hash to system state. And we'll use that here. But in the instance method, we'll call in memory with that value. Okay. Now this can no longer be used anywhere, I think. All the references will be broken. So we need like dot instance. Okay. Yeah, this probably makes more sense. Now the tests will also break. Yeah, I think we can use the empty one actually. Well, this is a test of the registry, which I guess we should be using the real one. Okay. In memory. This is the resolver test. So for this one, I think we want the empty image, so we'll just use dot instance. But then empty system, that kind of sucks. Actually, I can use any one. So in memory, and we'll have the empty state of map hash, like init hash, empty hash to empty system. We'll make these arbitrary. And then when I build the empty image, this will be this empty system, not the registry empty system. Okay, now the rest, registry in memory. So here, I think we don't really care. Like this could be any kind of input. Yeah, except it can't. Like if we save this, if we start with this system in the registry, we can no longer do this. So I think it would be the easiest way to just pass an empty value, an empty map. And here, finally, I think we also need the empty map. Okay, now there's a failure. Hash not found for empty system. That's supposedly impossible. Do we have empty hash? Oh, I see. Yeah, this cannot be like empty hash, empty system. It has to be registry empty hash. Or... yeah. That's it. It was just completions didn't hit here. Like there's... okay, now it's showing up, but yeah. Okay, this passes. I'm not super satisfied with these tests, but before we get to the target architecture, I'm not sure we can do it any better. And also, I'm not like too worried about this kind of code. Testing is, or I didn't mean for testing to be the main focus of this series, so let's just call it a day here. Okay, so I'm gonna write a to-do for the next episodes. Like we have this client methods. I think we might have to delete that, and also migration to Weaver. So hash calculation. That's gonna be the next step. So let's get back to the architecture diagram. Yeah, so we'll need the hasher. I think that's the most important part, and we don't need to introduce this and system storage first. We can just go with this. So yeah, let's go to the registry and add a hasher. I'm gonna start here in the same file, so then we can just extract it with some refactoring. And we're gonna hash the system state like this. And now the big problem, how do we actually hash the system state? So one idea is that we just take the hash code. I'm not a great fan. I'm not sure if it's going to work the way I want it to. Like if two maps, let me see. I would need to probably read up on the specifics of a hash code, but let's see this. So A to B. So this is the same every time, right? What if I do like B to C and then I flip it? So that's the same. Yeah, let's just check it. So hash code. There's something called a hash code equals contract. Okay. So okay, yeah, this has to be portable, right? So we need to be able to retrieve the same hash. It seems to work for this case, but whenever it's invoked on the same object more than once, it must consistently return the same integer. Okay, it doesn't have to be consistent. So I think this is already enough to disallow the usage of hash code for my use case. Right? Yeah, so for the hasher, we're gonna have a bunch of free cool tests. Like we're gonna actually hard code some values. This is the whole point. So I think we're gonna do a SHA-256 for this. I'm gonna need sync probably because I think there might be like some mutable state involved. And it's just gonna be a hasher. Actually, we can do this like that, so system. And now there's, yeah, this is exactly what I wanted to do. I'm just gonna take this suggestion. To vector. So there's this message digest thing, and we can get the instance like this. So yeah, this potentially is like side effectful. Let's see. It probably depends on mutable state, so this is already enough reason to wrap it in sync. Okay, and digest, like, the question is whether this is thread safe. Which probably it isn't. Oh yeah, it's not. It definitely isn't. Okay, yeah, so I'm gonna do it like this. It's gonna be bytes, okay. And yeah, that's simple as that, but also, I'm not sure about this part, like toString. That's kind of sus. Do I really wanna like stringify the whole system state, which is a map of strings to strings? This is a big question. Like, is it guaranteed that the toString is not gonna change? And I think it's not guaranteed. Like between instances of the application. So yeah, I need to do something in thinking on that. I was also thinking of like encoding it as JSON and then stringifying that, like with sorting. I guess like just sorting would be good enough to guarantee that toString is the same. Or we could do it in a more efficient way, like just concatenate all this and hash that. Yeah, that actually seems like a decent idea. So we'll take the toString, and before we do so, yeah, all. So just encode it like this. Yeah, just like concatenate. I mean, this is kind of like JSON. And JSON might actually be a more better way. Oh yeah, I forgot to do the sorting. So this probably has several flaws, but I guess we can worry about that later. I probably cannot sort a map, but if I convert it to a list first, I can. Yeah, that should be good. So this is the pure part. So system bytes. So I can extract this, add it, give it a type, and now do the boring part here. Probably want to import that. Okay, do you have the hasher? And this is gonna be a dependency of the registry if my memory serves me well. Yeah. And this is gonna be a replacement for this basically. So I can actually start with like a UID instance. That's gonna make it easier to swap out the implementation later, even though it's not technically doing what we need. How did I do it here? UID. Yeah, hash. Something like this. And we need the functor as well. So you can see that it's not deterministic because we are not even taking the system into account. So yeah, so I'll replace that here. We'll have a hasher. And we'll take hasher f hash system hash. Yeah, what? Oh yeah, and because this is gonna be deterministic, we don't need to do this lookup. That's good. And of course we are missing an apply method here. It's always doing the wrong thing. I could just want f and a given. Huh? Huh? Oh, it's using? Yeah. Every time. Okay, so it still wants a hasher. Yeah, hasher here. Okay, yeah, I think that does it. Now let's see the creation here. So given hasher, actually it's gonna be here. I think it doesn't really matter what I use. Let's use UID for now, but we'll change very soon. Now all the tests will also blow up, or not compile at all. I think I can actually start using the right one here, so. And now I'm thinking to just encapsulate the creation of all of it. I'm not sure, like we are not going to mock the hasher, right? I will pretty much always test it with the real one. We're just gonna have the backend customizable, so I'm not sure. But let's just keep doing this manually for now. I think we can share it because it's stateless. So this is probably fine. Let's see the tests. All of them. All green. Okay. So I think we can loop the server tests. And yeah, I think it's time to get rid of this. And what? I thought it only needed like a, oh, it needs a sync. That's true. Module on the executor. The question is whether I want to use sync here. That's probably fine. Unless I want to like a hasher for the whole thing. Yeah, that's gonna be fine. Just sync. At this point, I think it's fine to use sync. And also we don't ref make anymore, because it will be derived from sync. And this can go away. Okay. Yeah, it's working. Now if we go to the worksheet, it should be like fully deterministic. The values seem the same every time, so I think we're there. It's pretty long though. I mean, it's to be expected, but it's still pretty long. Can I actually lowercase that? So hash. I don't think it's working. Let's connect again. Yeah, that's better. How long is this? 64, okay. Cool. But yeah, the string is not being used for the hash like calculation. Like it's the output that just derived from the hash contents. So we have removed the UIDs, and now I think we can extract this to a new file. That's good. We probably don't need some of these implicits. And here we don't need this. So again, Scala 3 doesn't have these warnings, like unused import warnings yet. So we kind of need to do this on our own. Okay. Just run all the tests again. Okay. And hasher. So another thing I wanted to do here is replace this, like get rid of empty hash. That could be a problem, but maybe not. Yeah, this empty hash here. So empty system, I think this can stay. So I'll just put this finally into the companion object of system state. I think it deserves a place here at long last. Now all the references to this. We're gonna find some in the test, maybe not. Okay, maybe not. And the empty hash, this probably has more references. And it does. So we have empty, wow, isn't this unused? It is. But maybe not for long. So empty hash will be, well, we can derive this. So empty hash is just, wait, what is F? Okay, that's funny. I didn't even think about this, like this should be IO, right? I mean, it's not bad that it's working, but I don't think I want to use F, at least not yet. So hasher, well, hasher IO, empty system. Yeah. You know what? We could make this like a utility method in here. We'll take a hasher and we'll just return f of hash like this. So hasher empty system hash like this, and now we can use it. Okay. Also, the fact that there's a resource in here is kind of annoying. Because the state will be managed by something else, I think we can get rid of this resource right now. And maybe make it here, like... Maybe? Probably not. We can just call to resource here and make it an F. Yeah. Now this .use will become just flat map in all these places, and we can possibly refactor everything. Let's see. We have one flat map, two flat maps, and then map. But then we define an implicit. We have this. Yeah, this could possibly look better. So empty hash. Then we have the registry. Ooh, we can do given registry IO like this. And unless there's like still that annoying bug, which I think there is, this might work eventually. I'm just copy pasting stuff right now, so. And yield insert. I think this is it. What else do you want? Pattern expected. Well. Yep, it's still broken. So I think we need like unit. I think we have this in here. So there's like a hack to make this work. Otherwise, givens are not working in for comprehensions. So yeah. So I have this unit here, and now we can use this given in this line. Should be an arrow. Yeah, and this is an IO, but it wants a resource. Oh, because of this. I don't need the resource. Yeah, that's fine. Yeah, so except for this like unit line, I think we are in a clearer state than before. Okay. Build, maybe like this. Maybe this is not necessary anymore. No, it is necessary. Probably. What is this? Oh, it's still trying. Yeah, okay. Let me fix this for now. Apparently this is not necessary because of this line, so that's cool. Let's see if we still need it after the others. Have the registry, no resolver. Base hash. Build. Resolved. New base and yield. Yeah, we're gonna need unit here. So why is this not parsing? Illegal start. Is this just indentation? Okay. Yep, okay. Now we're good. Okay. And one more. I'm just gonna yield the assertion now. So we have registry in memory. Again, given registry. Resolver. And we need this hack here. We have the build, we have the resolver resolve. This is gonna be resolved. What else? That's it actually. Okay. Okay, that's not working. Impossible hash not found for empty system. This is the test of the resolver. Which test is it? Any build basing on the empty image. Okay. Oh, because this is still using the empty hash, that's fine. So this is to be expected. Yeah, this should not exist. So now this is fun. I can do hasher, hasher empty system hash, empty hash. The hasher could technically do some caching. Funny. The hasher could do hashing, but there's no need for that. And now, okay, that's not gonna work. So here, look up empty hash. Isn't this just the empty image? Yeah, I don't know. I don't want to do lookup on the empty hash like that. Yeah, now I'm thinking to make it like empty hash could be returned by the hasher but without the effect. But then again, we don't have access to the hasher here and maybe we shouldn't. So this is... Yeah, empty image is just the system state empty, right? Let's just return this. No need to overcomplicate. Okay. How many tests is that? Just one. So now we have another failure. So new base equals an empty system. But empty system is not the empty system. That's a problem. Okay. Yeah, so the registry thinks something else. So, okay. So I think we should just not involve the registry at all here. Like build empty, I don't know, empty system hash. Okay, yeah, I'm just gonna simplify this a bit. So this is gonna be an empty map. Yeah. Yeah, let's just pass an empty map. And this is gonna use system state empty. So we don't need this. Because the resolver is now, the registry is no longer being used here. So why do I need empty system hash in hasher? Just for the tests? No, okay, we use it for the initial one, okay. I guess it makes sense. But also the initial state, this should be just a list of systems. Or shouldn't it? Because the hashes can be derived from that. Let's see, do I ever pass anything else? Map. Yeah, now it's an empty map, always. In these tests, how about registry tests? I think I just used the instance method. Yeah, okay, I'm making it a map, a list. This is gonna be just a list. So initial state, yeah, for this I'm gonna have to do some traverse. That's not it. I think we need traverse. Yeah, just traverse. So state. Or no, this is better. So we no longer need this. Okay, yeah, I don't think we need initial state anymore. I think we can just insert stuff. So hash and system state. Right, this is just gonna be empty. And now in memory is also gonna be empty. But, and why do I need this? I don't. So flat tap here, registry. We're just gonna save the system state empty. Okay, and now the hasher, this is still failing, I guess. Oh, it's not compiling anymore. Yeah, this is gonna be an empty thing. Like I probably don't even need to insert the empty one. Also, I wonder what the hash is of that. So like system state empty and like hasher. Like this. Okay, so this is the empty hash. Good to know. Yeah, let's just pass empty. Okay, apparently it's all passing. Which is good, I think. Yeah, so it's kind of convoluted now. Like, what is this method used for now? This one. It's not. Okay, so let's remove it. So this is gone. I just added it and now it's gone. So do we ever actually need to special case the empty system? I guess we do, because otherwise the registry doesn't recognize that. Yeah. So the resolver will always know what the empty system is, because it doesn't involve the registry. But at the same time, the registry also knows what the empty image is. Yeah, I think this should not be like this. Hmm. Yeah, what happens if I don't do this? It's kind of unfortunate that the registry wouldn't have the empty image, right? But I guess if it's kind of artificial, then it doesn't really matter whether we have it in the registry or not, which is currently the case. So the only part that hard codes that is this, like empty image is system state empty. I guess that's fine. Also, how often is that used? Here's how you validate usage between modules. You remove the definition and you check what fails to compile. There we go. So this is the empty one because we use the empty image. That's fine. Anything else broke? No, apparently not. Which is acceptable. Okay. Yeah, I'm gonna call this like the major cleanup. I have no other idea. And I think we're actually ready to merge to main. Let me just run the tests again. So we do have stateless hash code calculation now. And I think we can merge, so. Okay. Let's see this part here. So this is gone, I think. Empty hash doesn't exist. And the registry, it doesn't have these empty things in here anymore. Instance is kind of artificial, like it has no reason to exist other than being you know, an abstraction over this. So in memory is going to be useful for us for the future. But at the same time, I guess in memory would just be like a backend of this, like the storage. So I'll leave it to do like merge, like extract storage, system storage. And instance is just going to pass maybe a different storage. This is going to hard code the ref based one in memory one. So yeah, we don't have this anymore. This doesn't exist yet, but it will be trivial to implement. Hash state, that exists. So let me use like a normal color here. That exists, and oops, I'm gonna make it the normal line as well. System storage doesn't exist yet, but I think we've cleaned up nicely, quite nicely. Now let's see if we can clean up something in the executor, like the usage of all of this. So registry lookup, that's fine. Resolver, resolve, interpret, save. Yeah, the problem is that we are still like running every build many times if we get the same one. We don't do any kind of caching on the build side. I would like to change that, like this was the whole point initially. But that's currently not the case. But yeah, I think I only have time for a simple task at this point. So what else do we have? Migration to Weaver, client methods. Yeah, I think we can do this. I think we can do that. Yeah. So let me try to do this. So in the executor, we'll have a new method. Also, we have a, I wonder if I have a type. Yeah, we have command, and it's only used here. But yeah, so I'll add a new kind of command. It's gonna be list hashes, maybe list images. So we're gonna have list images here as well. No parameters, just a list of hash. And now we have to implement the server side and the client side. I think we'll need the endpoint first. Let me try to implement the server with just default. By the way, I can do this. It should work. Oh no, it won't because of subtyping. Forget that. Client, I guess, same thing. Okay, what else? What? List images, list images. Huh? I'm gonna reconnect. Yeah, that's fine now. So yeah, this will be list images. It's gonna take no arguments. So this will be unit. System state, yeah, this is gonna be list of hash. And we're gonna have a get images. No input, out is JSON body of list hash. Now the hash, yeah, I think I wanted to change the serialization of this. So I'm actually gonna do that as well, and we'll see how many tests break, but maybe in a second. So we have the endpoint. Of course, nothing is gonna work. Yeah, this doesn't compile. List images in this one, okay. Okay, this is used for what? For routing and for compat. Okay. Let's just do this. Actually, we're gonna use this as the keys of that. So IO list hash is gonna be almost like this. So pure IO. Okay, let's hope that now we can get this to run. Okay. So in the client-side executor, I'm gonna implement this with run protocol list images, and there's no input. In the server-side executor, we're just gonna forward to the same method in the registry. So registry list, and we're gonna add that. And right now it's just gonna do this. Get the keys of the map. And now the compat test, I think I should make this work. So test list hashes success. I don't think this should be able to fail in any way. Do you mean it's not a method? Oh, it's images. Okay, that failed. Cannot convert the void output to value. I see. So we need to take like a JSON input in the protocol. in JSON body unit. I think that's the problem. It's not. Oh, this will be tougher than I thought. What the hell does that mean? This is supposed to be a quick adventure. Oh, it's not gonna be a JSON body. It's not gonna be a JSON body because this is a get. Oh. So what I really want to know is if we can run server and if we can call this endpoint. Other servers in use. Oh, it didn't close Docker. Okay. Oh, my Docker is dead. It hanged. Come on. I don't want to kill Docker. There we go. Alright. Gonna open a new shell. So I think the port is 8080. API list. Images. What? About content. Oh, accept JSON. Are we sure this is the same server? What if I do this? Okay. What else do we want? Oh, this endpoint is not added to all the endpoints. See, this is what happens when you don't. Yeah, I had to connect this to... Yeah. Now it's a different story. Of course it's gonna work. And if we create something, now it's included. Okay, that works. So bloop test, this should work again. Almost. So it seems to recognize one image. Let's see, and yeah, I guess it makes sense because the state that we started with has this good hash. Wait a second, test execute instance, run keys. Yeah, it's gonna have these two. That's strange. No, we shouldn't be doing that. How about keys? Let me try to collect. So I'm just gonna keep the ones that are right. So key hash, right state hash. And this is gonna be a list. So now the good hash is gonna be a thing. Okay, so this is just gonna succeed always, I think. I cannot force this to fail yet. These tests are not written in that way. But I think the generic server error handling is so generic that we don't need to, maybe we don't need to explicitly handle that in the tests. Can I do a pending test? To do later. I think I can do it in like in Weaver, but not in Immunit. I'm just gonna leave it to do. Like this isn't a real project. I can always try to do it later or just ignore it completely. That's also fine. So list images internal error. I cannot provide any input to this, so I cannot force this to fail. I guess I could in one way, like using an IO local, but that would make the whole thing more complicated. Let's just do it like that. What else? I guess I might need a test on the server side. So this would be, yeah, because this is so thin, like this doesn't have any logic. I'm not gonna test this in the server side executor for now. I'm gonna test it in the registry. So registry tests. I'm gonna do this. So list on an empty registry. Exactly like this. Like I'm not even gonna write this test myself. I'm gonna test the server. and only the registry. Did you see that? I wrote registry and it completed interpreter. That's so funny. But not the first time it happened either. So now test. This is good, but yeah, it's too complicated. Save plus list. Turns saved. Systems. That's pretty much it. That's very much it. Interesting, so that doesn't work because we need the hashes. And that works. So yeah, I think that confirms that we are good. Also, I forgot to test the hasher. Wait. Dev list images, where is this? Test executor. This needs to be a val. Okay. I mean, it doesn't have to be, I just prefer it. Add list images endpoint. And now the test for the hasher. Like just a couple concrete examples because it's pretty much the only way that we can test it. It's gonna be actually just a simple suite. Is it simple IO suite? There's something else. Fan suite. So test. No wait, I cannot use a fan suite. I need an IO suite. So test. Empty hash. Oops. So hasher, hash system state empty map. And this is gonna be, yeah, this. I'm not gonna compare like exact values. We could technically parse this in here and compare to the bytes, but whatever. Okay, empty hash works. Let's just have some more examples. So hash, yeah, pretty much this. Oh, also we should add these methods here, like something like this. We could involve the interpreter, but that's kind of crazy to involve it in the unit test of the hasher. I'm gonna add methods like this. So add here, string, and then delete. Well, this is gonna be called upsert actually. I'm gonna reuse this in the interpreter as well. Imagine if it actually generated the correct hash. I would be so amazed, but it didn't. We have something else. But it knew the empty hash, right? Like I didn't write this. I think I didn't. I think this was generated, yeah, by GitHub Copilot. Fun. Ooh, this is gonna be nice. So what I'm gonna do, like hash insert, delete, insert, something like this. It's empty hash. Something like this. So delete one, and this is gonna be the same as originally. What else do we need? Maybe 2 elements. Actually, I'm just gonna write this and let the tool do the work. So this is exactly what I'm going to use GitHub Copilot for, like do the boring stuff and allow me to do the smart stuff. Now I wanted to reuse these methods here. We will not need these lenses here anymore, so that's pretty nice. Insert key value. Just gonna run all the tests again. And I think we have just enough time to do one more thing. Which is changing the format, the representation of the JSON for the hashes. By the way, do we have that in the routing tests? Oh, we do. What is this? This is okay, run. Supposedly this is a hash. Okay. Okay. Yeah, so this is gonna change. Which is great. This is gonna break when I change the format. That's good. I don't look at the test results. I need to run them again. It's taking a while to run these tests. Could be faster, much faster. Okay, one more thing, right? Hash. It would be nice to have tests for like encoding and decoding compatibility, because I'll have to write this. Oh, we need parsing. Oh wow. Let's see. Parse. Okay, yeah, I think this checks out. I trust the machine. It looks okay. Maybe not too efficient, but there's no type for like SHA. I mean, maybe there is in something like this, but like Bouncy Castle, but I'm not using that directly. I guess we have this in SPFS, but it's kind of all private. I'm just gonna ignore it then. So write hash, of course, yes, yes. Parse int, yes. What if this breaks? Yeah, this could break, but I guess it will fail the deserialization, which is pretty fine. So let's move this. Gonna drive the schema. Oh, this is gonna suck. Let me change that. I mean, customize schema. We don't really use the schema, right? Because for Tapir we don't use the schema. We just use the codex, but it should be consistent, probably. Right, decoder. Okay, so decoder. We're gonna just do strings, right? And then map to parse, or actually emap. And for the encoder, we're just gonna do to hex as JSON. Okay. So just out of curiosity, I'm gonna run the server and try to create something. And we got a hash, this string. So now we should get that back, and we did. Now let's see if we can post and run. Oh, this is gonna be fun. So I'll just pass the string directly. That doesn't work. Yeah. It's been a long while since I last did this. Let me just do echo. Okay, it wanted JSON. Yeah, this needs to be a JSON string. Like this. Okay, that works. So that's pretty nice. But the tests are gonna fail. The routing tests. Yeah. And this failed. So this is in the server tests. Let's run that again. And I think this is like the only place here. So we just need to ask the hasher what this is. I'll do it in the worksheet. We had the hasher somewhere here. Okay, I lost it. Actually, I'm just gonna append at the end. So, SHA. Oh no, I don't need to actually involve the hasher. I have this. Just 2 hex. Yeah, it makes sense. 28 would be like 36. No, wait, that doesn't. 32 plus 8. That's 40. Now 6 times 16 plus 4. I saw that. I can't remember what this is. Yeah, that's 96. So this checks out. Yeah. So the conversion makes sense. So 2864. Okay, this works. Or I could just say JSON from string to 864. And yeah, just do it like that. Yep. Okay. Just to be sure, let's run all the tests. That's for hashing and a new format of hashes. And also we did this. Listing images in the registry. That's a pretty big episode, I think. Okay. All right. So yeah, this is it for today's episode. Thank you very much for watching, and I hope you enjoyed all of this. As always, leave a like, subscribe, tell your friends, tell me what you liked, what you didn't. If this is too long, also let me know. I can do shorter episodes, just do more of them. And yeah, if you have any ideas for what we should do next, like we don't have to do this, maybe there's something more interesting that we could be doing. I'll think about the whole like caching thing and how I want to approach that, so we don't waste too much time on the next episodes. And yeah, just let me know what you thought about this one, and I'll see you in the next episode, probably in 2 weeks. So yeah, thanks again, and see you next time.